Next, we are going to take a look at how to balance the redox reaction. Typically when you balance the equation, you will need to look at the number of elements that have to be balanced on both sides of the equation. However, when we consider redox reaction, because the electron is transferred, therefore we will need to make sure that both sides of equation will need to have the same total charge, right? So for example, if you're looking at example 3, we already have one element on the, we have one atom of aluminum on the reactant side. We already have another aluminum on the product side. Same thing for copper as well, one on the reactant side and copper, another one on the product side. So it seems like this reaction is already balanced, but it's not. Okay, the reason why this is not balanced yet, because this reaction right here is balanced only the element, but the charge are unbalanced. Okay, therefore you will need to make sure that the charge on this side of equation have to come out to be the same as this side of equation. Okay, so according to the law of conservation of mass, right? So everything have to be the same. Okay, including the charge as well. So in this case, it's obvious that this one is a redox reaction because you see that aluminum go from 0 to 3 plus, right? It's losing electron. On the other hand, copper is the one that gaining electron because the oxidation number is reduced, right? It's getting lower. Okay. So in order to balance the chemical equation, you will need to split the reaction into half reaction. You already see this previously when we're looking at how to determine which one is oxidation and which one is the reduction. So I'm going to do the same thing again. Okay, so because aluminum go from 0 to plus 3, so aluminum is undergo oxidation. So this would be one of the pair that we are going to write. And copper going from copper 2 plus to copper 0. So this one would be the reduction, half reaction. Again, a redox reaction need to compose of the two half reaction. One is oxidation half reaction and the other is reduction half reaction. One cannot occur without the other. Redox reaction have to have both of them occur at the same time. Okay, so now how can we balance it? Okay, so the easiest way is for you to split half reaction. Okay, so how can we do that? Let's start with aluminum. When we start with the half oxidation reaction, I'm going to write only the pair of that undergo oxidation. So it would be aluminum that is become aluminum 3 plus. Okay, so this would be oxidation. Same thing for reduction as well. Okay, so it's going from copper 2 plus, right, to copper solid. Okay, so once you separate these, next you need to write out the number of electron that is being transferred. Okay, so if you look at aluminum, right, so aluminum is become aluminum 3 plus, which means aluminum lose electron. How many? Well, it's going to be 3 electron because it becomes 3 plus. Therefore, in this case, losing mean is producing, which mean the electron would be part of the product. Okay, so 3 of them, because it indicates that aluminum loses 3 electron. That's why aluminum become 3 plus. Okay, now same thing for copper. We are going to do the same thing for copper. Copper going from copper 2 plus become copper 0, which means that it's going to accept electron. How many? It's going to accept total of 2 electron. Right, because as the positive add to a negative, the result would be 0. Okay, so within this, you see that, hey, it's not matching. Because how come that aluminum lose 3 electron, but only 2 electron that copper accept? Where's the other electron goes? So that's when you will need to start to balance the charge. Okay, the easiest way to balance the charge is to make sure that the number of electrons are equal, because at the end, whatever lose electron, the same number of electrons have to be accepted by another element. So in this case, you will see that we have 3 electrons versus 2 electrons. So the common number would be 6. Therefore, in this case, what you need to do is you need to multiply this whole equation by 2 to make the number of total of electrons equal to 6. Therefore, your new equation for the oxidation half reaction would be 2 aluminum, okay, that become 2 aluminum ions and plus 6 electron. Okay, do the same thing for copper as well. For copper, you are going to multiply this by 3 because you will need to make number of electron total of 6 electron. Therefore, you will have 3 copper 2 plus 6 electron. Okay, that is become 3 copper solid. Okay, so next, what you will need to do is you will need to combine these two equations that have the same number of electrons. Okay, so this is 6 electron now, this is also 6 electron. It indicates to us that 2 aluminum will lose 6 electron total, and that 6 electron will be accepted by 3 copper 2 ions. That's what it means. Okay, if you combine these two, you are going to get the overall redox reaction, which is equal to 2 aluminum solid, okay, plus 3 copper 2 plus, okay. And because if you look at this, 6 electron on the reactant side, this 6 electron on the product side, therefore the electron will be able to cancel out. So we don't need to include the electron. Therefore, the overall oxidation, the overall redox reaction will not have any electron appear on the equation. Is because of that. Therefore, in this case, you are going to end up with 2 aluminum 3 plus, okay, and then plus 3 copper. So this would be the balanced redox reaction. How do you know it's balanced? Well, we need to check the number of elements. So we have 2 aluminum here. We also have 2 aluminum. We have 3 copper. We also have 3 copper. So that's good. Next, we will need to look at the charge as well, or the total of oxidation number. The total of oxidation number on the reaction or on the reactant side is you have 0 plus 3 times 2. Total would be plus 6, right? Because you have plus 2 from copper, but there are 3 of them. So total would be plus 6. And on the reactants, on the product side, let's take a look at it. On the product side, you have the same thing, right? You have 2 aluminum, but each of them is 3 plus, so total would be plus 6 as well, plus 0, so total would be plus 6. Therefore, in this case, this is the balanced redox reaction because you have both number of element balance on both sides and also the charge, the balance on both sides of equation as well. So this is the answer for the balanced redox reaction. Okay, so I'm going to go ahead, write the the coefficient in front of the example 3 equation. So it would be 2, would be 3 here, and 2 here, and 3 here. Okay, so that's it. That's the balanced chemical equation. I'm going to give you a few minutes here to finish example 4. After you finish it, please check your answer against my key. Please pause the video to complete example 4 and resume it again when you finish it. Now let's check your answer. Example 4, you will see that iron 3 plus become iron 0. So iron undergo reduction because the oxidation number decreased, indicating it's receiving electron. And bromine going from -1 to 0 is indicating that the oxidation number increased, which means that it's losing electron. So that would be the oxidation half reaction. Now, if you rewrite the oxidation half reaction and reduction half reaction, this is what you will get here. So I pretty much just copy from what is given, right? So I did not change anything at all. So next, what you will need to do, okay, so I'm going to start with the oxidation half reaction. Oxidation half reaction, you will need to first make sure that the number of elements are equal. So I'm going to add 2 in front of the bromine ions because we have bromine, right, with the subscript 2 here. And it's indicate that this one right here has negative charge, right? So and negative becomes 0. Therefore, bromine is losing an electron, right? So one bromine would lose an electron. But because we have 2 of them, therefore the total of electron that is lost would be 2 electron. Okay, so again, because bromine losing electrons. So electron would be on the product side, and each bromine losing one electron, right, becomes 0, -1 becomes 0, so it would be 1 electron. But since we have 2 bromines, so total would be 2 electrons. Okay, so this would be a balanced oxidation half reaction. Next, we are going to take a look at reduction half reaction. Reduction half reaction, we have iron 3 plus become iron 0. Therefore, it means that iron 3 plus received 3 electrons. Okay, because again, these two add together have to equal to the reactant side, the product side oxidation number. So 3 plus 3 minus, total would be 0. Okay, can we combine this yet? The answer is no. The reason for that is because the number of electrons are not equal yet. Therefore, you will need to make sure that the number of electrons on both of the half reaction are the same. So the common number between 2 and 3 would be 6. Therefore, I'm going to multiply the top equation by 3 and multiply the bottom equation by 2. Okay, so in order to get the total number of electrons equal to 6. Okay, so therefore in this case, the top equation would become 6 bromide ion aqueous, and it would become 3 bromine molecule, Br subscript 2 liquid, okay, plus 6 electron. And for the second equation, you are going to get 2 iron 3 plus, okay, plus 6 electron total, become 2 iron solid. Okay, so again, the next thing is, since you already have half reaction that contain exactly the same number of electrons, then you can combine them. So you can combine these two. Okay, so again, the reason why number of electrons have to be the same, because whatever is being lost, it need to be accepted by something at the same amount of the electron. Right, so that's why we need to make sure the number of electrons are equal. If they are equal, then you don't need to multiply by any factor at all. Right, you can just combine them. In this case, if you combine them, you will see that electron will appear on both sides of equation. One is on the reactant side, the other is on the product side. So therefore, I can cancel electron. And if you add these equations together, the total you would get 6 Br minus, okay, plus 2 Fe3 plus. Okay, and it would become 3 Br2 plus 2 Fe solid. Okay, make sure that you check the both charge and the element before you answer this. So we have the element 6 bromine on the reactant side. We also have 6 bromine, right? 3 times 2 is 6. That's good. 2 iron, perfect. Next, check the charge. Okay, so 6 minus, right? So 6 multiplied by negative, so 6 negative, plus 2 multiplied by 3 plus, that would be plus 6, minus 6 plus 6 equal to 0. So the charge of this, the total on the reactant side is 0. Okay, so let me use the different color. Okay, so the charge of this would be 0. And same thing, the charge of this would be 0 as well, because you have 2 neutral molecule, right? The overall charge on both sides are equal now. Therefore, this would be the answer for the balanced redox reaction, because both charges on both sides are balanced, and also the number of the element also balanced as well. So to answer this, I'm going to rewrite on the equation on the example 3. So you need 2 iron, you need 6 bromide ions, 2 iron solid, and 3 bromine molecule. The previous examples are the examples for the simple balancing redox reaction. Here we are going to look at more complicated balancing redox reaction, and these are the reactions that involve with oxygen or hydrogen. In order to balance the redox reaction that involve with oxygen or hydrogen, you will need to consider the type of solution that is in. For example, acidic solution would have a different way to balance the redox reaction than in the basic solution. First, we are going to take a look at how to balance redox reaction in acidic solution. The beginning steps of how to balance the redox reaction in acidic solution is very similar to what we did previously. You will first need to assign oxidation state for all atoms, and then identify which one is being oxidized, which one is being reduced, right? Or assign the two half reaction, and then split the two half reaction, and then we are going to take a look from there by adding oxygen and hydrogen. So let me walk you through that. So first, I'm gonna go ahead assign the oxidation number for all element here. So again, this reaction involved with the polyatomic ions, but these polyatomic ions appear on only the reactant side, not on the product side. Therefore, you will need to determine the oxidation number for all element in this case. So I'm going to start with copper. Copper is free element, so it would be 0. Between nitrogen and oxygen, you need to assign the oxygen first. So oxygen would be -2. There are 3 of them, so total would be -6. But overall have to be -1. Therefore, nitrogen have to be +5 in order to balance the oxidation number to give you the equal to the charge, right? So +5 plus -6 is giving you -1 total. Next, copper 2 plus, it would be +2 for oxidation number. And between this nitrogen and oxygen, again, you will need to assign oxygen first, so -2 for each oxygen. But since there are 2 of them, therefore in this case, overall for oxygen would be -4 to make this molecule to be neutral. Oxidation number for nitrogen would be +4. Okay, so therefore in this case, +4 add to -2, 2 of them, total would be neutral. So next, you will need to determine which one that undergo oxidation and which one is undergo reduction. Copper become copper 2 plus. Copper lose electrons, so copper would undergo oxidation. And the nitrogen is the one that is gaining electron from nitrogen +5 to nitrogen +4. In this case, nitrogen is undergo reduction. Okay, so we already have two half reactions. So I'm going to start with the same thing that we did before by writing out the two half reaction. So I'm going to start with the oxidation. Okay, so oxidation half reaction. Oxidation half reaction is copper become copper 2 plus. Okay, so for reduction, okay, half reaction would be NO3 minus become NO2. And this reaction is in acidic solution. So the next step is we need to start with balance, make sure that all the elements are balanced on both sides of the equation. Oxidation is already balanced because we have copper on one copper and the other one is also another copper. For reduction, however, we have one nitrogen, but we have 3 oxygen and 2 oxygen. So you will need to balance the number of oxygen by adding water. So in this case, we have 3 oxygen here. We have only 2 here. Therefore, you will need to add 1 water on the reactant side to make the overall number of oxygen equal to 3. Okay, so 2 plus 1 equal to 3, and this is already 3. Okay, so that's good. And the next thing that you will need to do is you will need to make sure that the number of hydrogen is equal, right? Because we have the equal number of nitrogen, equal number of oxygen, but we don't have equal number of hydrogen yet. Because this reaction is in acidic solution, so what you will need to do is you will need to actually remember from the acid base first. So acidic solution means that the reaction contain pretty much proton, right? So therefore in this case, in order to balance this, you will need to add proton to make sure that number of hydrogen are balanced. So if you have 2 hydrogen from the water on this side, I would need to add the proton on the other side. Okay, so I need to add plus H plus on the other side, and we will need to add 2 of them, right? Because there are 2 here and 2 here. Now the reduction half reaction now have all the elements are equal on both sides of equation. So 3 oxygen, 2 hydrogen, 2 hydrogen. Okay, so after you already balance the element, the next thing is you will need to make sure that the charge balance. You will need to make sure that the charge balance by adding the electron. Okay, so similar to what we did earlier. So we are going to go ahead add electron to all of this. Okay, so the number of electron that we are going to add. Okay, so because copper become copper 2 plus is indicate that copper lose 2 electron. Okay, and nitrate plus 5 become not nitrate, nitrogen oxidation number of plus 5 become plus 4. Therefore in this case you will need to add 1 electron, right? So we're gonna add 1 electron on this side. Actually I don't have enough space here, so I'm gonna let me erase this for a second, so that way, and also erase this arrow too, so that way I can add electron at the end in this case. So we're gonna add 1 electron. Okay, so it become that. All right, so when you already add the electron, you will also need to make sure that the number of electrons are equal, and also the number of charge would have to be equal as well. The first one, you have copper 0, copper 2 plus 2 electron, that's also equal to 0 as well. So the charge of this reaction is already balanced. Okay, now if you're looking at reduction, the charge of the nitrate is -1, electron is -1, so total would be -2, but proton, there are 2 of them, it would be +2, so overall would be 0. This overall would be 0 as well, so that's good, that's perfect, right? Because the charge on this side is equal to the charge on this side. Okay, so that's already perfect. The next thing though, that before you can combine these, you will see that we cannot combine yet, because the number of electrons are not the same, they are not equal. Therefore in this case you will need to multiply the second equation by 2 to make the total number of electrons equal to 2. So you are going to end up with 2 nitrate, okay, plus 4 proton plus 2 electron become 2 NO2 plus 2 water. Okay, so now you will have equal amount of electron, right, on this side and this side, right, on the reactant side, and the same as on the product side. Then you need to combine them. So to combine the reaction, we are going to call this overall redox reaction. So the overall redox reaction would be copper solid, right, plus 2 nitrate plus 4 proton in aqueous solution, so it would be AQ, and the electron are cancelled because electron appear on both sides of equation, therefore we can cancel these two. So next I can write the product now, so it would be copper 2 plus in aqueous solution. Okay, so sorry, so that is the plus side right there to not confuse you. Okay, and plus 2 NO2, which is gas. Okay, and plus water, 2 water actually. Let me erase this, so it would be plus 2 water as a product. So this would be gas and then plus 2 water. All right, so let's check our answer before we answer this. So you need to make sure that the elements are the same, right, on both sides. So 1 copper, good. 2 nitrogen, good. 6 oxygen, 4 oxygen plus 2 oxygen equal to 6, that's good. 4 hydrogen, and we have 4 hydrogen, perfect. The element already balanced. Next, you will need to check the charge. The charge on this side of equation equal to, okay, the charge on this side equal to 2 times -1 is equal to -2 plus 4. Overall would be, so it would be -2, right, from the nitrate, and then plus 4 from the proton, so equal to, overall would be +2. Okay, so this is the reactant side charge. Now for the product side, we have only 2 plus from copper, so this is easy, so the product would be +2 as well. Therefore in this case the element already balanced, also the charge balance as well. Therefore this is going to be the correct balanced redox reaction. Okay, so this would be the correct balanced redox reaction. You can either put the coefficient back into the example as well. So copper would be 1, it would be 2 nitrate, right, plus 4 proton become copper 2 plus 2 nitrogen dioxide plus 2 water. Right, so that would be the correct balanced chemical equation. Next, we are going to take a look at how to balance redox reaction in basic solution. The step of balancing redox reaction in basic solution is very similar to in acidic solution, except there is one more step that you will need to take into account. When you add the proton to the equation to balance the hydrogen, you will need to add the base, right? Base is hydroxide ions in this case. Right, so we learned from the acid base. Base is the hydroxide ions. Therefore, in this case, you will need to add hydroxide ion in order to neutralize the adding proton to make the overall to be either neutral or basic solution. Okay, so let's take a look at example 6. Okay, I'm going to start with the same process that we did earlier. So we have chlorine and oxygen, and the overall is -1. So I'm going to go ahead, start with oxygen. So oxygen would be -2. Chlorine would be +1 because the overall, these two add together need to equal to -1. Okay, so those would be the oxidation number for each of the element. Next, I'm going to start with chromium. Okay, so chromium and hydroxide. So I'm going to start with so we have the overall charge of -1. So let's go ahead and start with chromium first and then the hydroxide ion. Okay, chromium and hydroxide ion, the hydroxide is -1. Okay, so hydroxide is -1. But because we have 4 of them, therefore the total for these would be -4, right? Because the hydroxide, each of them -1, we have 4 of them, so total would be -4. Therefore, in this case, -4 add to what? It give you the -1 charge. So in this case, it would be add to +3, right? Because +3 minus 4 equal to -1. So in this case, the oxidation number for chromium would be +3. And then next thing is to determine the oxidation number of hydroxide ion separately. So from the hydroxide ion, we know that the overall have to be -1. Therefore, oxygen in this case would be -2 and hydrogen would be +1. Therefore, the overall, if you add these two together, is giving you -1 for each hydroxide ion. Okay. Do the same thing for chromate ion as well. Okay, so we have Cr and oxygen. So you need to assign the oxygen first, followed by the chromium. Oxygen is -2. There are 4 of them, so total would be -8. But the overall is -2. Therefore, the oxidation number of chromium would be +6. If you can't think of this fast enough, what I highly recommend you to do is just list it out, right? For example, hey, what is the oxidation number of chromium? Leave chromium as the unknown value. Add to, oh, we have 4 oxygen, and each oxygen is equal to -2, right? These two add together have to equal to the overall charge of -2. Then you can solve for the chromium, and you will see that in this case, it's gonna come out equal to +6. Okay. All right. So next one is chloride ion. It's obvious that chloride ions would have oxidation number of -1 in this case. Okay, so then we can determine half oxidation and half reduction. So you see that oxygen, of those oxygen has the same identical oxidation number. Okay, so that we don't have to worry about that. What we can see is that it's the chlorine that changed oxidation number, and also chromium as well. Chlorine going from +1 to -1 is indicate that the chlorine is undergo reduction. Okay, so in this case, chlorine would undergo reduction. Okay, because it's gaining electron, is become higher oxidation number. And because chromium going from 3+ to 6+, therefore chromium would undergo oxidation because lose electron. All right, now after you already get the half reaction, next is you need to split them out. Okay, so I'm gonna write the oxidation half reaction, which is CrOH 4 minus, okay, become CrO4 2 minus, okay, and for the reduction, half reaction, it would be ClO, oops, sorry, let me leave a little bit more space here, so it would be ClO minus, and then it would become Cl minus. Okay, so that would be so similar to the previous examples. So the next step is we are doing the same thing, right? So we need to make sure that the elements are balanced. So if you're looking at the element for the oxidation half reaction, chromium, one chromium on both sides, that's good. We have oxygen on this side. We have 4 oxygen on this side. We have 4 oxygen on this side. So oxygen is already balanced. Okay, but the one that is not balanced is hydrogen. Okay, oxygen is already balanced, so you don't need to add any more water. Okay, so you can just leave as it is. But because hydrogen is not balanced, so you need to add the proton. Okay, so similar to balancing the acid solution, right, in acidic solution. So because we have 4 hydrogen on this side, so you will need to also add 4 hydrogen on the other side. Okay, and because this is the base, if this in basic solution, you will not see proton floating around. Because the proton indicate acidic solution, hydroxide indicate basic solution. Therefore, we will need to neutralize this added acid. Okay, in order to neutralize this, you will need to add hydroxide. Okay, so you have 4 proton, you're gonna add 4 hydroxide ions. Okay, and you have to add both sides as well, because if you don't do it, then you are not going to have the balance equations. Next, we need to start to neutralize between the added acid and added base here. So when proton react with hydroxide ions, this species right here would become water. Okay, so this would become full water. Okay, so before we move on, the next thing is you will need to make sure that you check that the elements are equal, and then we can look at the charge by adding electron. But first, let's check element. Okay, so element, you have chromium 1 chromium here. You have 4 oxygen plus 4 oxygen, that's total of 8. In this case, you have 4 oxygen from water, 4 oxygen from the chromate. Total would be 8 oxygen, that's good. We have 4 hydrogen, add to 4 hydrogen, that would be total of 8. And we have 4 times 2, we have also 8 hydrogen as well. So in this case, the oxidation half reaction have the balanced element. The next thing is we need to balance the charge, okay, because both charge and element have to be balanced, right? So in order to balance the charge, then you will need to take a look at what happened to its oxidation number. Okay, so if you're looking at oxidation number that we determined earlier, we see that chromium going from 3 plus to 6 plus is indicate that the chromium is losing electron, 3 of them, right? So 3 plus to 2 plus 6. So therefore, in this case, you will need to add 3 electron. You need to add 3 electron on the product side, because it indicates that this chromium 3 plus losing 3 electron become chromium plus 6, right? So that's why I'm adding 3 electron on this side. Okay, so then for the reduction, we're gonna do the same thing. Oh, actually, before we move on to reduction, let's make sure that the charge actually balance. Okay, so the charge of this is -1 plus -4, because 4 times -1 is equal to -4. So total would be -5, right? We have -2 here. Add to 3 negative, total would be -5 as well. This would be neutral, right? So therefore, the charge is already balanced. That's good. Next, let's move on to the reduction half reaction. Okay, so for the reduction half reaction, we are going to do the same thing. Okay, so what we going to do is that we are going to take a look at the element first. Chlorine, that's good. We have one oxygen here. We don't have oxygen on this side. Therefore, in order to add oxygen, you need to add water. Okay, so I'm going to add water to this. Okay, so I'm going to add water to this. So now the number of oxygen are equal, right? Because we have one oxygen here, one oxygen here. That's good. But we have different number of proton. Okay, so there are two hydrogen on this side. Therefore, I would need to add proton on the other side, and it have to be two of them because we have two hydrogen on this side. Okay, and again, this is in basic solution. How much, whatever number of proton you add, you need to add the same amount of hydroxide ions to neutralize it. So you need to add two hydroxide on both sides. Okay, the reason why you need to add on both sides because you will need to make sure that they are balanced, right? So if you add into one, you will need to add into the other one too in order to neutralize this. Okay, so therefore in this case the neutralization reaction of this would produce two water. Okay, so now before we move on, let's check the number of element. Okay, so we have one chlorine, good. 2 times 2, 4 hydrogen. We have 2 hydrogen plus 2 hydrogen, that's 4, that's good. We have 2 oxygen on this side. We also have we have 2 oxygen on this side plus 1. Total would be 3 oxygen, right? So 1 plus 2 oxygen, total 3 oxygen. And on this side, you also have 3 oxygen as well. 2 come from the hydroxide and 1 come from water. Therefore, the reduction half reaction here is already balanced for the element. The next step is to balance the charge. In order to balance the charge, you will need to add electron. Okay, so we do this several times again, right? So in order to balance charge, you add electron. And if you're looking at the oxidation number that we determined earlier, chlorine is positive 1, become chlorine 1 minus, is indicate that chlorine receiving 2 electrons. The reason why it's 2 electrons because it's going from negative 1 to 0. That's the first electron that is received. And when it's received one more, it's going from 0 to negative 1. Therefore, in this case, we will need to add 2 electrons, okay, from on the reduction half equation. Okay, so we're going to add 2 electrons on this side. Okay, so now let's check the charge before we move on. Okay, so we have 2 negative plus 1 negative. Total would be 3 negative on the reactant side. On the product side, we have 2 negative plus 1 negative. Total would be 3 negative as well. Therefore, this is the balanced reduction half reaction. Okay, next we are going to combine them, but we cannot combine them yet because the number of electrons are not the same. The number of electrons on the oxidation half reaction is 3, but the number of electrons on the reduction half reaction is 2. You need to find a common number between these two. Total is 6 electrons. Therefore, you need to multiply this whole equation. Okay, so you need to multiply the reduction half reaction, multiply this whole thing by 2. And do the same. You are going to multiply the reduction half reaction by 3 to make the number of electrons are equal. Okay, so in this case, your oxidation half reaction result would equal to 2 times the chromium hydroxide, okay, plus 4 hydroxide ions become, not 4, it would be 8 now because you multiply 2 in, let me erase that. So again, because you multiply 2 to 4, total would be 8. Okay, hydroxide ions, and then it would be 2 chromate ion, and you are going to multiply 2 to 4 water. Total would be 8 water plus 6 electron. Okay, you're going to do the same thing for reduction half reaction. So you're going to get 3ClO minus plus 3 multiplied by 2 water, that would be 6 water, plus we also have electron here as well, so total would be 6 electron, become 3 chloride plus 3 water plus 6 OH minus. Okay, now let's take a look at what are in common, right? So which species appear on both sides of equation before we can combine. In order to combine these two, the species that we are going to get rid of would be 6 electrons. Okay, so 6 electron transfer from oxidation half reaction and it's going to reduction half reaction, so we can cancel this. Okay. The next thing that you can look at is, hey, we have 8 water on the reactant on the product side. We have 6 water on the reactant side. Therefore, you can also cancel this as well. The total water left on the product side would be 2, right? Because you have 6 minus 8, the leftover would be 2 water. Same thing for the hydroxide ions as well. We have 8 hydroxide on this side and we have 6 hydroxide on this side. Therefore, you can cancel some of that as well. We can cancel 6 hydroxide here and this would have only 2 hydroxide left. Then you are going to add all of them together. Okay, so now you are going to have 2 CrOH 4 minus plus 3 ClO minus. Okay. And it's going to add to 2 hydroxide that we have left from here. Okay, so these add to the hydroxide left, right? Because we already canceled this. And it's going to become 2 CrO4 2 minus, right? That come from here. And next would be chloride ions. Would be 3 chloride ion plus we have 2 water from here, but we also have another 3 water here. So therefore, in this case, total number of water would be 5 water on the product side. And these already cancel, right? So these cancel with that. And so all you need to do is just add water. So let's check whether this reaction right here is the balanced redox reaction or not by looking at the number of elements first and then do the charge. Okay, so chromium 2 to chromium, we have 2 chromium here. We have 4 oxygen, but there are 2 molecule total, so it would be 4 times 2 would be 8. 8 plus 3, that's 11. 11 plus 2, that's 13. We have 13 oxygen on the reactant side. Now let's take a look at oxygen on the product side. Product side has 4 times 2, 8. 8 plus 5 is also 13. Okay, so the number of oxygen is good. Okay, next number of hydrogen, we have 4 times 2, that's 8 hydrogen, plus another 2 is 10. Okay, so this side have 10 hydrogen. This side has 5 times 2 is 10 hydrogen. Perfect. Okay, we have 3 chlorine. Perfect. Okay, so that means in this case, all the elements are balanced. The last thing you have to check is the charge. Okay, so we have -2, add to -3, add to -2. Total would be -7, right? So all of these add together equal to -7. Let's take a look on this side. Okay, so we have 2 times 2, that's -4. Okay, plus -3 from chloride ions. Total would be -7 also. Therefore, the charge of this reaction is also balanced as well. Therefore, this reaction right here would be the balanced redox reaction. So that would be the answer. This topic is quite challenging. You will not be able to do the exam without practicing. So I highly recommend you to actually complete the DIY problem on page 110 on your own. So that way you can try it first, right? So you know where you are struggle. Then you can check your answer against the key, or come visit me during office hour on Thursday from 11 a.m. to 2 p.m. on Thursday. The link to the meeting on Thursday is posted on Moodle. So you can just click on the URL of the Zoom meeting and you will be prompted to the window that you will see me. So good luck with study. Thank you for watching.